G'day guys. Thought that before I went any further on this GPX-4000, I'll point a few things out on part of the strip down. And some of this is pretty important. Now, first thing is you need to get, well I do, need to get to the whole input stage of this detector. And hopefully you can see everything. I've got a sort of a long shot at it. Yeah, it's basically, it just clips on there. I just flipped it over like so. And all the input stage is under this. So we're going to remove it. Now this is important that if you just grab this hot melt glue with a tool of any type and just lift it, well, there's a whole heap of parts. Many components under the hot melt glue, and I've seen it done before where people pull it off and it pulls the parts up off the board and rips the tracks up. Makes a big mess. So to get these off the board, this little tie here doesn't go through the board like on the later model detectors. It just holds the wires down on this ferrite sleeve. First thing to do, good old isopropyl alcohol. This is your friend when it comes to removing hot melt glue, and it works really well. So what you do, just spray it around like so. Don't be shy, can't wreck anything. And what you got to do then, where there's no components, is just lift it a little bit, tiny, just like a millimeter. Don't push in like that, you'll wreck the board. So just like that. We'll get some movement. Okay, it's cracked a little bit. Just to be careful where it's cracked. Get the isopropyl in there. Wiggle it around a bit. And very slowly, up she comes. Now, you can see here that that's where the op amps were. There's hollows here. All the small parts that were stuck in this, or this was stuck to them. And yeah, you can see all the little parts. I hope you can see all the little parts there. That any of these, if they came away, would be stuck in the hot melt glue. You do not want to see that. You want this hot melt glue to be just hot melt glue, no parts stuck in it. So that's the first stage. The other thing too on this as well, it also doesn't have any white paint sitting there. So this was obviously painted after the hot melt glue, and once you remove that, you can actually see all the components in there. So it's also stuck on this ferrite sleeve. I don't want that there, go away. So best thing to do with that is cut that cable tie like so. And it really sticks hard. So what we do, we'll get the isopropyl and we'll just plonk it around there. If you do it near the cable tie, it's got a good chance of going in. You don't really want all this hot melt glue stuck everywhere, so magnetic. And like so, off she comes. So that is how you remove this stuff. Just got to let the isopropyl just make its way in a bit, and eventually it all comes off. Even the rubberized glues they're putting on the later model detectors, it really sticks hard. And if you want to remove it, again, use the isopropyl alcohol, but it's a slow process. You've got to spray it. You lift it like a little bit and spray it again. And eventually all the isopropyl alcohol crawls in, and even the fumes of it cause a debonding of any sort of silastic or a silica or hot melt glue, and eventually it all comes away. Even here, that's popped off, and so was that. It's probably just because of the fumes. All these components here, that's the 5-volt pulse output MOSFET there, and the one behind it is for the 15 volts. And as you can see, they're just glued in place with hot melt glue, and also the voltage stabilization MOSFET there, big blob of hot melt glue on it, sticking it in there. And yeah, big blob of hot melt glue there. That is a ground connection point. So I don't know what that's covered up for. So that's going to come in handy for my tests. So we do want a ground connection on these boards. The earlier boards had little standoffs soldered on in various places, but you just see, I haven't done a 4000 for a while, so just see how it is. So all you got to do is just give it a bit of a push. It's cracking the white paint off, of course. We've got a little bit of movement there. Yeah, it's breaking the glue. So I'll give it a bit more of a squirt. It's a matter of just making a little opening and it comes up. There we go. See, I've cracked it. It's just coming off now. Go around here. There's a surface mount resistor or capacitor there. We don't want to hurt that. A bit more. Now we're right under it. And there we go. So you take off that, I don't know what they glued that for, but if you can see that, that is a ground point. So you could stick your oscilloscope clip lead onto that and then use that to poke all the various test points. I mean, it's got some test points here. You can have a look at the integration pulses here. Thing is, you've got to scrape them down too because they've got white paint all over them. Very fine sandpaper is one way to do it, or a small Dremel with a tiny wire brush. Don't get wire filaments going in the board, but if you don't scrape these down, you can't connect. So yeah, it is a while since I've done a 4000. I think the last 4000s, Dave done the 4000s. So yeah, but all these capacitors here, these big ones, big electrolytics, you really want to not have them wobble like that. If they wobble, it'll break the legs off on the bottom. You can heat them up and just push them down a bit harder, and run some. Just hit it with a hot air gun. Get them up to about I don't know, 50 or 60 degrees Celsius. And when it's warmed up, put some hot melt glue with a hot melt glue gun in the gap, and because you've preheated it, it'll stick like crazy. It'll stick really well. If these are cold and you put hot melt glue on, it doesn't bond. As soon as the hot melt glue touches the surface, it goes cold. It doesn't get an ample amount of time for the glue to get in every little microscopic nook and cranny and hold it. It just basically makes a gluing. Gluing, is it gluing? It actually makes a bond by surface tension rather than actually embedding itself in the into the basic. I suppose it's the molecular structure of the paint they're put on. So yeah, that does work. Also on this one as well, you can see the yellow around here. They are electrolytic capacitors. They have been merrily degassing over the years. So I'll check the value of these. I'm pretty sure See, everything's covered in white paint. Yeah, they are electrodes. So there's 1, 2, 3, 4 electrodes sitting there, electrolytic capacitors, and also these big ones are very high quality capacitors. They're low ESR type capacitors. They have to be because they are storing the energy for the transmit pulses. You know, you're transmitting through a MOSFET into something of about half an ohm resistance. You don't want a light duty capacitor here because your waveform's going to crash to zero. Well, not quite, but it's going to taper off rather severely. Won't be able to energize the coil properly. So these are important, these capacitors here. This one not so much. This one within reason. That's a 200 volt rated cap. I think they're about 100. Are they 150 or 80? I can't remember. Whatever. Because it's all covered in white paint. You've got to say, oh well, you know, whatever it was. But some of the obvious stuff there, you know, but that makes life easy, having that area there clean. So we get in there. And I was saying too about these detectors, the 4000 is a hybrid type development between the later 4500, 5000 detectors and also between the old GP detectors. If you have a look at the overall design, you know, if you have a look, say, basically capacitors, not the power stages, here back, it's very, very similar. You know, there's different placement of things. You know, you got your the CPUs that basically does a lot of audio function. That's your main processor there, control function, and switching waveforms to all this these 4053s here. There's a lot of basically, you know, these things here. What are they again? Oh God, I can't remember the number off the top of my head. 40 something or others anyway. So yeah, most of it's similar, but you know, you've got adjustment pots here as well. On the later detectors, they don't have that. They did have provision on the board for it if you scrape away the paint, but it doesn't go anywhere. So they've done it. I think they just digitally trim everything. The front end around here, just this bit here, which is clean, all that is just about identically the same up until that point there, that way backwards. It's all the same. All in here is different. The power supply part of it here, 2022s and 39, what are they? Whatever they are. Yeah, gee, 372s and 2022s. Anyway, whatever they are in here. That's your power supply section. That's identical. There's not really much difference there whatsoever. This big bank of electrodes here, the same. There is a diode in the middle of these, usually tucked down under all the hot melt glue. And it may not be on these ones. Let me have a look-see. No. But it's a little bit different. It's got these, let me have a look here. It's got a couple of inductors there. I think they're on the GPXs as well, but just in a different place on this detector because it is a hybrid. So if you actually ignored the power output stages, because the later ones don't have big bulky MOSFETs sticking up like that. They have surface mount MOSFETs. But if you looked at it sort of like that, it's basically the same. And when it gets over here, it's different. And yeah, it's similar but not quite. If I actually had my where's my little board? I've got a GPX board here. Where is it? Where is it? Oh, here's one. Oh, Yeah, got lead poisoning. Grabbed it here and stuck in my thumb. Okay, if you have a look at the two side by side, I think this is the one that came off the quad bike at a million mile an hour and self-destructed. But you can see that power supply, the same. Transformers and inductor, same. Voltage control for the flyback, same. Capacitors, same. Actually, this one here looks like it's got a bigger cap on it, but maybe it's an optical illusion. I don't know. Probably. I think it might have. But anyway, and then you have a look here, you got these big MOSFET devices here, and here you got little surface mount ones. But it's basically the same circuitry. It's all the same. Put that over there. But as you can see, when you get round here, it's all very different. I don't know if you can see here, but see there's three little, it's little triangle lumps in the paint there, little dots make a triangle pointing upwards. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's equivalent to these pots over here. But on here, they're basically preset and forget, or they're just a set resistor or two resistors or something making a voltage divider or whatever it does. It puts the right set point there. Maybe it does, maybe it doesn't. I don't really know. But these ones here on the older one are adjustable. So yeah, if you have a look at that, that's basically a hybrid between the two. 4000 and the 4500. So this one here as well, I think that's a TLE 2027 if you want to know. That one there. What else we got here? This one here has that extra quad op amp on the 4500, and this one doesn't. So I had a look at the how this one here actually works, and it does interface into the input stage. I do think it's when they came out with that SETA thing, that's what it's based on, that op amp there. It's got some bipolar transistors connected to it. I just basically had a sniff around there. I didn't actually trace it out to see exactly what's going on, but obviously the detectors work without it because it's not implemented here. But it could be something else done in software. Who knows? Who knows what they've done? But yeah, very, very much of a muchness. So, like I say, this is only an educational thing. It's just even in here, you got your your CPU, NPU type things here, crystal oscillator for it. Then you got all this resistors and that down here, and maybe an inductor and a couple of capacitors. On this one here, the later one, it's very different. And mainly around this stage here, that's completely different. It's nothing like it, but functionality will be very similar, if not the same functionality. Just a different layout, and obviously it's got a lot more op amps on this one too. To give maybe it's a layer of filtering, maybe it's just a interface to maybe the first lot of those op amps are a lower gain, then a higher gain. They want to do everything bang in one hit. And obviously there are RC networks around these, so obviously they are filtered. So you can have a look at what goes in and what comes out if you really want to. I've never felt it's necessary to do that. But if you wanted to, you can. And like I say about where these provisions are for potentiometers. There is none there. It don't need it. It's done in a different way. Maybe everything's so damn close. They just put a resistor network in there and say that'll do. But the 4000 as a detector really performs really well. It's not bad. It doesn't have a backlit LCD, which is probably one of the biggest drawbacks on the design, whereas the later ones do. But you can put in backlit displays if you really wanted to, which obviously you have to take that board out and you have to take out you have to unsolder all those little tiny connections there and pull the module out, and then you got to put in a resistor um, for the backlighting. I think is there. I don't know if there's actually on the 4000 if there's actually provision to control it. I think you might have to do your own. But I've got some backlights for these. I'll show you. If I get them over here. Amazing what I've got around here. But that's a backlight unit for one of the displays. I don't know if you can see it, but can you see these two extra pins here? One there, one there. That is for um, a little row of LED diodes in there, and the glass LCD just goes on the top, and you can put in a backlight display. All you do is connect power to it. You got a backlight. You can do that on the 4000s. So yeah, because they didn't come out with that. The other thing too, I've actually somewhere around. I don't know. Someone might have knocked them off, but as in stolen them. I had some backlights that were orange. They were like basically the same as what we used to use on service stations, gasoline stations or petrol stations. Uh, the old LCD with that were orange, and you could see them in daylight. Well, I had a whole heap of backlight orange ones, but in the early days, I put them on a few people's detectors because you could read them in full sunlight. Then it was really good. Uh, and yeah, I don't know if I've got any left. This might be an orange. This one might be an orange one. It'd be one of the last few left. And I've also got this might be of interest too to anyone who is interested. It's educational, but I'll show you something else too. Okay, well, it's been sitting in a drawer. That's the actual display. It's covered in dust. Um, so that's all the pins that you would have to resolder if you wanted to put a new display in. So yeah, I should get rid of all that dust off there, shouldn't I? But my little wiping rag has disappeared from here. I don't know where that's gone. Oh, finger will suffice. But I can tell you a few interesting things about these displays. These displays were actually for something else, would you believe? And yeah, you can actually, if I actually put voltage on the pins, I could actually fire this up just with low level voltage. I could just do it with a battery and do it with my fingers. It'll light up if I want to put a couple of volts through it. But if you have a look on it, it's got pictures of antennas for like a car radio. There's all sorts of stuff on it. They weren't made specifically for these detectors. These are made for something else. I remember the guy who was importing these. It was a long time ago. Um, I think he was in Nunawading or somewhere, or Ringwood. I have to look it up. But he was getting these displays, and that's how come I've got orange ones because he said, Well, I've got a whole heap of orange ones, and I've got different colours, different variants, different levels of blue, and all sorts. I think when he was supplying, to minelab, I think at the time, and he had all these different variants. So yeah, that's the actual displays. I don't think anyone will have any of these kicking around. Long gone. But yeah, that's what they are. It's just an LCD display. Nothing fantastic, but I'll keep that for future. I don't know. Don't break your displays, people, because if you want to buy them, they won't sell you this. You have to buy the whole damn thing. It'll cost a fortune. I don't even know if they supply them. But like I was saying before, if things aren't supplied by the manufacturer, and I'm talking about these, the Chinese, God bless their little black hearts. I don't really have anything against the Chinese, but God, they copy everything, as we all know. That if you go on some websites, the Chinese ones, they'll sell you this board with a display in there. They'll sell it to you. And the trouble is, though, they've done the software. It doesn't say, it won't say GPX something or other. It'll say GDX or GFX or something like that. It'll still work, but it makes your genuine minelab look a lot cheaper to anybody. If you ever wanted to sell it, they turn it on. It said GDX or GFX or some crazy thing. But what you can do, which I might as well tell you what you do. If you do buy one of these boards, it's up to you if you do or not. There's a direct fit. It goes straight in, not a problem. And what you do, you're probably going to laugh, but change that little Atmel chip there. That's the micro, holds all the information for the display. Just heat it up with hot air, drop it off, and heat the other one up and put it on. You got to be very careful doing it. It's very, very fine leg pitch and that, but I've done that. And you can turn an old, well, basically, if you've got a stuffed board, it's got a stuffed display, and you want to resurrect a display, you just get a Chinese one and just change the micro. Um, yeah, it works, but yeah, I don't know. I'm just that's educational. Okay, I'm not saying do it. I'm saying it is possible from a educational point of view. So yeah, that's been sitting in the drawer for a while. Got dust all over it. Funny, it's got dust all over it, and it's in the drawer. But anyway, I'll put that back in the safe spot with a collection of backlights. Yeah. So anyway, that was just a quick and easy on pulling off the hot melt glue to get at the components on these without destroying the board, which some people have done. But yeah, I went a little bit off tangent onto other subjects, of course, but it's all related. The other thing too, I think I have mentioned before, with these, if you drop your detector, it'll break the screen. It'll break that where I had on the LCD. It's got a little black part. It's very thin. It'll break, and the tracks in there are just a beryllium copper type of layer on top of the glass, and you can't fix it. You can't stick to it. You probably use carbon paint and do it, but it'd be too difficult. You wouldn't want to do it. So yeah, I've always said on these, the screws here, you want to put little bits of rubber, little round circles of rubber or something under and over both sides of the board basically, and don't screw them down tight. Leave them a little bit so it's wobbly. And if you go smack with this on the ground, if you drop your detector, it won't break the screen. If that's hard connected, it'll break the screen. Trust me, I've seen people do it. A 4-foot drop, 1.2 meters to be, if you want to be metrified, will break the screen in a lot of cases. So if it falls like that, whack, it'll break. that will break it. Everything will break it. I had a fellow send me a detector, and he put it in a post bag, and he dropped it in a mailbox which had been cleaned out. In other words, it fell about 3.5 feet down to the bottom and hit the bottom. And yeah, when I got it, it had a broken screen. So I backtracked on that and said, "Oh, how'd you send this? I mean, you know, it had minimal bubble wrap around it. It wasn't really protected." So we had to put another screen in for him. So yeah, just be careful of screens in the older detectors. Apart from that, this one is in here for full upgrades. So I better get started, and that can go back in the reference pile. I just use that for reference. I have got the other one which I've cleaned all the parts off, but I don't think uh, I've got to be careful doing that because you know we'll say that even though it's conformal coating, it is done to protect IP. Even though the Chinese have completely got all the designs and make them willy nilly, but uh, it is to protect the IP, I suppose, as well. So you know, if I made something up and I went and ground all the numbers off, and someone said, "Oh, well, we put blah 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 there," well, you know, it'd probably really piss you off. So we'll just leave most of it all covered up in white paint. Uh, but it is what it is. Anyway, I'm going to get stuck into this one. This is going to have variable frequency put in it. I'm going to put uh, 8 chip modules into it, and I'm going to change some other parameters in the detector. What else is he? I don't even know what he wants. It's written on the back of this. Okay, good. On this one, I don't have to put variable gain in this one. So yeah, I was going to make it a very low noise, deep gold machine. That's what he wants it for: low noise, deep gold. You know, like the video I did with that 5000. That was super quiet. Basically, I'm going to do the same to this as what I did to that. So it should be a very very good detector when it's done. So yeah, like I'm not joking. I got to say this you just. I'll show you what just came in the door. I'm gonna go out here and get it. Yeah. Here we go. Yeah. There's a box from the US and some more anyway, some more detectors. So these things just keep coming in all the time. And go down there. The shelf behind me's got heaps of them. So guys, bear with me while I get these detectors done for you. It's just a lot of work at the moment coming in, and I was caught up in some R&D, so we are upgrading the upgrades a little bit more for you. So make these things dead quiet. Yeah, I actually had David do a test for me on one that the latest modified 5000 against one that was done a little while ago, and yeah, I wish it was in his own words, but he did a lot of swearing. He says freaking nothing like it. He said the newer one. He goes, oh my god, it's just so different and quiet. So yeah, it's finally paid off. That I really did. I stuck my head right in. Even though I got to work for all this white paint stuff on all these detectors, which is a pain. You know, you look at anything, you say, oh, what value is that resistor? You know, you got to stab it with something and measure it, and then you don't know if it's getting loaded by the circuit because of, you know, is that the correct value or is it something different? Whereas if it wasn't all covered in white paint, you just read the numbers off it. Make a lot of sense, and you could sort of go, oh, that goes there. Oh, you know, we can run a bit more current through that and shut it up a bit, or or something like that. Or we could add more capacitance there, cut out some of the higher frequency noise or whatever. But working on buckets of white paint is painful, and actually the thing is with the later versions of the minelab detectors, uh, specifically the 7000 and the 6000, because they're not dipped in white paint. Thank God someone, I think we'll put a Trumpism in there. Common sense prevailed, right? Because it's all done in those BGA type chips now, and it should not be copyable under any circumstances. Uh, so, that's the IP protection, the way they've designed the boards. And the thing is, they are now serviceable, properly serviceable. You can actually replace parts, and that's a bonus. Um, you know, People used to really balk at these boards being covered up because it would stop user serviceability. But now, all the minelab detectors, when they're out of warranty, I will specify that when they're out of warranty, you can, if you want to go in for a deep dive, still got the bloody black modules, but there's only a preamp in there and associated switching. But the rest of it, for hard and fast power supply failures, which are fairly common, um, you know, most of the dry joint type problems that crop up, um, you know, um, high voltage side problems that happen because it's just things get stressed and break down. Transmit switching, stuff like that. All the common failures now are easy to repair, right? It's not hard. So, well, sometimes it's hard to track it down, but um, you're not going to, pay a brain surgeon $20 an hour to remove a blood clot out of your brain or something if you ever need it. So it's same with this. It's damn bloody difficult sometimes, and other times it's not. It just depends. Um, yeah, so that's that. But yeah, the later detector's good. Thank God the bloody white paint's gone. Well, the white epoxy, it just makes life easy, And apart, guys, on this epoxy too, right, I might as well give you a bit of a fill in on something. I haven't mentioned this for a while, but if you do want to get rid of this white paint, you want to remove it off the board if you want to get to track work and that. Don't do this on the components; you'll wreck the board. Get a little hot air gun, heat it up to about 450 degrees, and a very flat scraper blade. Heat this up, and just scrape it. Comes straight off. Uh, Leaves a little bit of a film there, but the film then comes off with a cotton bud and isopropyl alcohol, and it just looks like a brand new circuit board. So that's if you want to fix these ones anyway. Uh, Normally, you're not going to go and work around components with that sort of temperature. So what you do then, if you suspect a component's dead or misbehaving, you'd probably poke it with your oscilloscope leads on wherever you're looking at, and just remove that IC. On a lot of these ones too, you can use hot air, but it does stress everything around it. What you're better off doing, because it's got glue under it. Remember, they put super glue type stuff under all the parts, so you're going to break the glue bond, and it really stresses it when you heat it up. Better way to do it is scrape the legs down on the chips. Get a screwy, and I'm not going to do it, but you can go just scrape white paint off, and what you do then, get some resin, nice soldering resin. Like, have I got one here? Get this stuff. This stuff's really good. That's what I've been using lately. This is one of our customers put us onto this. Amtech, right? AliExpress. It works fine. If you go into the shops to buy it, they'll charge you $16 for that, and I think you can get two of these for about 6 out of China, and it's the same stuff. And yeah, even though I'm halfway down, I've done God, I don't know. I've done so much work using this, and because it comes out just a little dab you need, It lasts for ages. It's far more efficient. So yeah, there you go. It's got an expiry date on it of the 9th of 2026, made in China. Um, there you go. If you want to make an inquiry, jiangsolder.com. So there you go. Complies with ROHS Directive 20295 EC. Is that EC or whatever? I don't even know what that means. But there you go. China trademark. Oh, it's got a US trademark number as well. So yeah, they've trademarked their delivery system. So you don't use this as a COVID shot. It'll probably kill you. But yeah, this stuff works really well. So what you do, if you scrape your legs, bit of a squirt there, bit there, and flood it with normal solder, 60/40, or you can get that solder that is low melting point solder. I think it's got bismuth in it or something. But anyway, there's a low melting point solder you can get, and it makes it because it mixes with the high melting temperature non-lead solder. It makes these easier to come off. So you basically flood it, and if you get a dual iron like I've got here, like that thing looks like the devil, or the back end of an earwig or something. That will you just heat it and rub it back and forth until the chip pops off. Or if you're really quick on the normal line, you go dab, 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 like back and forth, and eventually it'll get hot enough and come off. Sometimes they're really stubborn because they're glued on, but you know I've done this. You got to be careful. Get a flat blade screwdriver, like something like that, and put it between the chips. See that there? And you put the most slightest twist on that, because when you heat these up, if the glue doesn't want to let go, if you just keep a little bit of pressure, makes sure that solder does not go hard. If it goes hard and dry or solidifies, um, there's every chance you'll pull the tracks off. But if you can, best to use something like this, because you can keep both sides molten, and you just put a bit of pressure and it'll go pop, and she'll move, and you just pick it up, gone. Clean the board up with some solder wick and some more resin, and put a new chip on it. Which, yeah, it's better off just to clean it up absolutely perfect, and not replace it using hot air, because you've got to protect everything else. If you're doing one of these and it's near those plastic trim pots, you'll melt them. So don't do that. You can put up like heat diversion. I've used tin strips and all sorts of stuff, and just put it like so they don't get hot. But yeah, just a lot of cases, you can just put resin there, hold them in, tack one leg, work the other side of the chip, and just drag a ball of solder straight down like that, straight down the legs, and it will stick all the legs, and just at the end there, you just want a little bit of solder wick, and flick the iron tip into the solder wick so it pulls the excess solder, and that'll get rid of the last little blob of solder on the end. And they'll all be soldered beautifully. And just do the same on the other side. And that's good and quick, easy, low stress way to do it. Hot air is not recommended really, unless you've got a lot of space around the components. Like if you really wanted to, you could pull the op amps out here using hot air, because there's no paint on the legs. For a start, you could just help them along. Just put blobs of solder on the legs, and the chips will come off a lot easier. Because they're only such small legs, it's very hard to heat the whole thing up with hot air. But if you've got a big blob of solder sitting on each side of it, the solder will just, it's got more surface area, gets more hot air, drops off quicker. So it's safer, and you won't rip the tracks off the board. So anyway, there's enough waffle. My throat's still sore. I haven't coughed yet, which sends me into a coughing fit, because one cough equals one tickle equals another cough, and it goes on going. So, like on my last video, it got me at the end, I tell you. I thought it was quite funny, so I left it on, didn't edit it out. But yeah, buddy, I guarantee you it's the kids. David's got it as well. He goes, "Oh, my legs feel heavy and I've got a sore throat." And I said, "Oh God," I said, "That's exactly what I've got," and it's happened. Um, we haven't really been in close proximity, and we've both got the same thing. So I think, and the kids go to the same school, right? So that tells me everything I need to know. Anyway, that's enough of this. Yeah, but yeah, people were asking me about 4000s. Are they any good? Yes, they are. They're not a bad detector. It's just a totally different design. It's a bit like a GP, but not sort of. If I put a GP there, but it's two boards, yeah, it's a bit complex looking, because because you've the two boards, a lot of stuff basically gets all been shrunk down into these two chips here. So a lot more functionality in a small space. So they've all got it down on one board, which is rather good. Yeah. Okay, I'll leave it there. I'm going to get stuck into this. My voice is starting to go, I can tell. Yeah, and I don't want to start coughing. Anyway, all good catches.